Hi, welcome to part 2 of this series on controversies in physics. In part 1, we have confirmed that the gravitational attraction between two bodies depends on the masses of both bodies. Furthermore, since we stand upright anywhere on the surface of the Earth, and because the greater the mass of a body, the stronger is its force of attraction, these clearly authenticate that mass is what generates gravity. We also discovered that Einstein built his entire general theory of relativity based upon a misconceived foundation. As I pursued my investigation deeper into the gravitational phenomenon, the logical train of thoughts revealed unconsidered parameters, which is the topic of this video. This is Benoit Launier, the black sheep of physics. So without further ado, let's look at another discrepancy. Welcome back. Newton formulated an equation to evaluate the pull exerted on an object gravitationally bonded to the Earth. In his equation, what we are interested in is the variable r in the denominator, which, according to Newton's presumption, represents the radial distance between the object and the center of the Earth. This means that Newton assumed that Earth's center of gravity is located at its center, and that it coincides with its center of mass. During my investigation, I realized that Newton's assumption in regards to an object on or close to the surface of a celestial body is severely inaccurate. The only condition in which his proposition makes sense is when the object would be situated exactly at the very center of mass of the celestial body, or it would be at a distance very far away from it. Obviously, the mass closest to an object is the mass that produces the most attraction upon the object. Now imagine you are standing on the surface of the Earth. Since the magnitude of the gravitational attraction reduces exponentially as the distance increases, this means that the cubic kilometer of dirt just below your feet, let's call this mass of dirt gravity cell A, has a much stronger gravitational pull upon you than a similar cubic kilometer of dirt, gravity cell B, on the opposite side of the Earth. For example, the magnitude of the attraction cell A imposes upon you is about 650 million times that of cell B. This means that if we were to locate a point where the combined efficiency would average out their attractions acting upon you, in no way would it be located at a distance midway between them. If we would divide the entire planet into similar gravity cells, all the gravity cells of Earth's near hemisphere, since they are closer to you, would produce more attraction upon you than the reciprocal cells of Earth's far hemisphere. The differences in gravitational attraction acting upon an object do not only apply between the reciprocal cells of a celestial body's near to far hemispheres. They apply between each and every gravity cell of the planet. If we consider the cell just below your feet and the one below it, they also exhibit a difference in their respective gravitational magnitudes acting upon you. If we make these gravity cells smaller and smaller until they reach the size of atoms, the atoms closest to you produce more attraction upon you than the ones below them. This means that the reduction in gravitational magnitude per the distance of separation applies between each and every particle of both bodies mutually as quanta, that is, entities made up of countless smaller and smaller parts. Therefore, if we were to calculate the attraction efficiency from all of Earth's gravity cells acting upon you, the point average of their attractions, center of gravity that is, would be much closer to you than Earth's center of mass. In order to evaluate the gravitational attraction between two bodies with the utmost precision, we would need to evaluate the attraction magnitudes that each particle of the one body imposes upon every particle of the other body, as well as the attraction magnitudes that each particle of the other body imposes upon every particle of the one body. This kind of evaluation would be incalculable. This is why it becomes more practical to synthesize centers of gravity to evaluate the attraction between bodies gravitationally bonded to one another. Let's take the Earth and the Moon for example. Their attraction would depend on the distances that separate each particle that make up one body from every particle that make up the other body, and this reciprocally. If we were to average out the attraction that each and every particle of the Earth imposes upon each and every particle of the Moon, we could synthesize their collective efficiency as if they would be pulling from a single point within the Earth. This point average represents Earth's center of gravity in regards to the Moon. Since the mass of the Moon is also a component of the attraction between them, the Moon exhibits the same phenomenon in regards to the Earth. The Moon's center of gravity in respect to the Earth would need to be evaluated exactly the same way. In conclusion, as per the universal physics theory, in regards to an object on or close to the surface of a celestial body, Newton's center of gravity, assumed to always coincide with the celestial body's center of mass, regardless of the configuration, is consequently inaccurate. This brings about a whole new set of parameters to consider in order to evaluate more precisely the gravitational magnitude between two bodies. Therefore, not only must we consider the mass of each body and the distance that separates them, we must also consider the distribution of each body's mass, as well as the displacements of their respective centers of gravity, one in regards to the other, which vary depending on the distance that separates them. This was just a brief introduction to the gravitational phenomena. In my book, The Universal Physics Theory, 5th edition, gravity's unconsidered parameters are examined in much greater details. Thank you for watching. I hope it was informative. And if you liked it, please share it with others.